Now, in this video, we are going to discuss the spur gear design steps. So if you are being asked in exam to design spur gear pair or to calculate module, then you have to use this step-by-step spur gear design. Here I have included that which formula on which page number of Bhandari design data book you can find out, that I have included over here. So this video is special because every step is fixed, and on which page number which formula you can find out, that is also fixed. So it will be easy for you to calculate numericals on basis of this step by step procedure of the spur gear design. Now the first step is to calculate number of teeth on gear, ZG. Z is number of teeth and G is gear. So calculate number of teeth on gear ZG from gear ratio. Gear ratio, in some books it is referred as G, in some books it is referred as I. In Bhandari design data book on page number 17.3 you can find out this formula. I is NP upon NG is ZG upon ZP, where G or I is the gear ratio or speed reduction ratio, NP is the speed of pinion in RPM, NG is the speed of gear in RPM, ZG is the number of teeth on gear, ZP is the number of teeth on pinion, and DG and DP is the pitch circle diameter of gear and pinion. Now, sometimes the number of teeth on pinion will be given to you in numerical, but if it is not given, then you will need that. Then you have to assume it. For 20-degree pressure angle, you can assume Z minimum as 18 teeth. You can assume ZP, number of teeth on pinion, as 18. M is D upon Z. Module is pitch circle diameter D upon number of teeth Z. So if I cross multiply M into Z, I'll find out D. So D is M into Z. For pinion, if I want to find out, then the formula will become DP, pitch circle diameter of pinion, is module into ZP, number of teeth on pinion. And if I want to find out for gear, then I have to use the formula DG is MZG, where DG is number of pitch circle diameter of gear, ZG is the number of teeth on gear. You can find out this formula on page number 17.12 of Bhandari design data book. The other formula is PC or P is pi D upon Z, where PC is the circular pitch, D is the pitch circle diameter, and Z is the number of teeth. The second step is to assume face width B if it is not given. Actually, in numerical it would be given, but if it is not given, then you will have to assume it. You can assume face width B from 9 module to 15 module, where B is face width and M is module, and this formula is given on page number 17.11 of Bhandari design data book. So you can assume it as B is 10 module. Best formula to assume is face width B is 10 times the module. Step 3 is to calculate the bending strength. Sigma B is SUT upon 3, where sigma B is the bending endurance strength and SUT is the ultimate tensile strength. If the material is same, then you'll have to use only one formula. Means material of pinion and gear is same, then this formula is enough. But if the material of pinion and gear is different, then ultimate tensile strength for pinion would be different, SUTP, and ultimate tensile strength for gear will be different, SUTG. Then in that case you'll have to use this formula as sigma BP is SUTP upon 3 and sigma BG is SUTG upon 3. This formula you can find out on page number 17.12 of Bhandari design data book. The fourth step is to calculate the Lewis form factor capital Y. Lewis form factor formula for 20-degree full depth pressure angle is 0.484 minus 2.87 Z, where Z is the number of teeth. Now for pinion, you will have to find out YP, and for gear, you will have to find out YG. The only difference would be in terms of ZP and ZG. So for pinion, the formula will become YP is 0.484 minus 2.87 ZP, and YG is 0.484 minus 2.87 ZG. This formula is not given in Bhandari design data book. So remember, you should learn by heart this formula. But in Bhandari design data book, this table is given on page 17.12. For 20-degree full depth pressure angle, you can directly find out the value of Lewis form factor Y from the number of teeth Z. So you can see if the Z is 15, then you can directly note down the formula for Y as 0.289. Same way, if the value of Z is 20, then you can directly get the formula of Lewis form factor Y as 0.320 from this table. Sometimes instead of Lewis form factor capital Y, the tooth form factor small y, you will have to use it, and that y is actually the tooth form factor. So Lewis form factor capital Y is pi into small y, that is tooth form factor. You can see the small y, the other side is actually 0.154 minus 0.912 upon z. So Lewis form factor is pi into 0.154 minus 0.912 upon z. So if you're finding for Zp, then it will become Yp. If you're finding for Zg, then it will become Yg. For 20-degree pressure angle, we saw this 20-degree full depth pressure angle, we saw the formula. But what if the 20-degree stub pressure angle numerical is given? Then the formula for Lewis form factor capital Y will be 0.55 minus 2.86 upon Z. And for 14.5 degree pressure angle, the formula will become 0.39 minus 2.148 upon Z. So in the numerical, you should carefully see which pressure angle is given, and accordingly you should select this formula. Remember, these formulas are not there in Bhandari design data book. Lewis form factors are not there. You should learn them by heart. Fifth step, you have to decide whether the pinion is weaker or gear. If the material of both pinion and gear is same, then you don't need to refer this step, because in that case, when the material of pinion and gear is same, always the pinion is weaker in design. But if the material of both pinion and gear is different, then you will have to do this comparison of sigma BP into YP and sigma BG into YG. You know, sigma B is bending stress for pinion into Lewis form factor of pinion is YP, and sigma BG is bending strength for gear, and YG is Lewis form factor of gear. So you should multiply sigma BP into YP and sigma BG into YG and compare it. If the value of gear is more, then you can say pinion is weaker in design. You can see in the first step. And if the value of gear is less, then you can see the gear is weaker in bending according to the second formula. So this is the fifth step, and it is necessary to decide here before calculating the beam strength whether the pinion is weaker or the gear is weaker, and we do it in this fifth step of the spur gear design. This formula is also not there in Bhandari design data book, so you should remember this, how to select which one is weaker, pinion or gear. Sixth step is to calculate the beam strength. Beam strength is given by SB or FB, where B is beam and F or S is the strength. So it is given by MB sigma BY, where sigma B is the bending strength, M is module, B is the face width, and Y is the Lewis form factor. You can find this formula on page 17.12 of Bhandari design data book. After calculating beam strength, we have to calculate the wear strength. It is given by W, FW or SW, where W is wear and F or S is strength. So FW or SW is equal to B into Q into dP into K, where Q is the ratio factor. It is always suggested to use for external gear. Internal gear numericals are not asked mainly. So for external gear, the formula is 2Zg upon Zg plus Zp, where Zg is the number of teeth on gear, Zp is the number of teeth on pinion, Q is the ratio factor. B is the face width, it is in mm, dP you have to write down m into zp. We have seen in the first formula, pitch circle diameter dp is m module into zp, that is number of teeth on pinion. Q ratio factor, like I told you, you have to use the first formula, which is for external gear, 2zg upon zg plus zp. Always you have to use this formula. And K is the load stress factor. Load stress factor, I'll tell you how to calculate. You can find this formula on page number 17.12 of Bhandari design data book. Now I told you load stress factor K. You can find out load stress factor K if endurance strength, surface endurance strength sigma C, Poisson's ratio, pressure angle alpha or phi is given, modulus of elasticity, pinion and gear, EP and EG are given. Then if these values are given in numerical, then you should use this formula for load stress factor, which is sigma C square is sine alpha cos alpha upon 1.2732 into 1 minus Vp square upon EP plus 1 minus Vg square upon Eg. You can use this formula. It's given on page 17.13 of Bhandari design data book. But sometimes instead of endurance strength, Poisson's ratio, instead of all those things, BHN is given, Brinell hardness number is given. So if the Brinell hardness number is given, then you should use either of three formulas on basis of its material. In your numerical, if your pinion is of steel, gear is of steel, then you should select this 0.16 upon BHN upon 100 whole square. You have to use this formula. If in your numerical it is cast iron pinion and cast iron gear, then you should use the formula for K is equal to 0.21 BHN upon 100 square. And if it is of steel pinion and cast iron gear, then you have to use this formula 0.18 BHN upon 100 square. So you have to see the formula of BHN, of load stress factor K on the basis of the material. And if the two BHN values are given, then remember you have to always use the largest BHN value for calculation. This formula you can find on page number 17.13 of the Bhandari design data book. You will only be able to find it for steel pinion and steel gear. Remember, for cast iron pinion, cast iron gear and steel pinion, cast iron gear, you have to learn by heart the formulas. The last two formulas you have to learn by heart. Eighth step is to calculate the tangential load Ft. In some books it is referred by Pt, from pitch line velocity small v. So Pt or Ft, that is the tangential load, it is P upon V, where P is the power and V is the velocity, that is pitch line velocity. You can find out this formula on page 20.12 of Bhandari design data book. Remember, it is on page number 20.12. You won't be able to find on in the chapter of Spur Gear design. It is in the page 20.12 of the Bhandari design data book, where V is pi dp np upon 60,000. NP, you should always use the formula for NP in the Spur Gear design. DP, that is pitch circle diameter, that is M into ZP, and V is your pitch line velocity in meter per second. This is also there on page number 20.12 of Bhandari design data book. Now once you have calculated step number 8, the step number 9 is to select the service factor, load distribution factor and velocity factor, Barth factor. Service factor in Bhandari design data books, it is called as CS. Load distribution factor, it is not there in Bhandari design data book, but in some books it is given as KM. And velocity factor, Barth factor, it is CV or KV. So CS or K is the service or application factor. You can refer page number 17.14 for Bhandari design data book. You have to select it between some values, but it is good to assume 1 or 1.5 if the values is not given in the numerical. Usually the value of CS or K would be given, service factor of application factor would be given. But if it is not given in numerical, it's good to assume it either as 1 or 1.5. Same way, load distribution factor or load concentration factor, it would be given in the table, but if it is not given in the numerical, then you should select it as 1. CV or KV, velocity or bath factor, you can find it on page number 17.14 of Bhandari design data book, and it is as according to the formula of velocity. Now suppose if the velocity is less than 10 meter per second, then you should use the formula of 3 upon 3 plus V. If the velocity is less than 20 meter per second, then you should use the formula of kV is 6 upon 6 plus V for Spur Gears. And if it is greater than 20 meter per second, the velocity is greater than 20 meter per second, then kV is 5.6 upon 5.6 plus under root V, where V is the pitch line velocity in meter per second. And you know how to calculate. V is pi dp np upon 60,000. That is the formula on, which is given in the step number 8. I have explained you. Now the 10th step is calculate effective load, P effective or F effective. In some books it is P effective, in some books it is F effective. In Bhandari design data book it is given as P effective. P effective is CS upon CV into PT. Now this is preliminary estimation. 10th step we are doing preliminary estimation of the effective load, where P effective or F effective is the effective load. You can see PT or FT, it is the tangential load. KA or CS is the service factor or application factor. KV or CV is your load distribution factor or bath factor, and KM is the load distribution factor. So 10th step we are calculating this, and this you can find out on page number 17.13 of the Bhandari design data book. Now this is not there in the Bhandari design data book. You have to learn by heart this formula 11. To calculate module, you have to first compare whether your beam strength was greater or your wear strength was greater. Suppose your beam strength is weak, it is less value than the wear strength, then you can say the gear is weaker in bending. Then you should use this formula. FB or CB is F factor of safety into F effective, right? FS is the factor of safety. But if you see that the gear is weaker in wear, then you should use this formula. How to decide if gear is weaker in wear? You can compare it between beam strength and wear strength, and if you find that the beam strength value FB is more as compared to FW, then you can say that the gear is weaker in their wear, and you can use this formula. FW is FOS into F effective. So in this step you have to decide whether the gear is weaker in bending or gear is weaker in wear. The above two formulas are also used to find factor of safety against bending failure and factor of safety against wear failure. You can just put the formula of FB or FW and F effective values, and on basis of that you can find out the formula for factor or value for factor of safety. So in 11th step you will be able to find out the value of module. Once you find out the value of module, the 12th step is to calculate the dimensions of the gear. Module you have found out, then you can find out addendum HA as 1 into module, addendum HF as 1.25 into module, pitch circle diameter of pinion DP as M into ZP, pitch circle diameter of gear DG as M into ZG, face width as 10 times the module, and center distance as DP plus DG divided by 2. This all formulas are there on page number 17.6 of Bhandari design data book. 13th step is to calculate the maximum tangential load. Maximum tangential load PT max or FT max is K Km into FT. You know K is or CS is the application or service factor. Km is the load distribution or load concentration factor, and FT or PT is the tangential load. So FT max or PT max you can find out on basis of this formula. So the 13th step is to calculate the maximum tangential load. Calculating the 14th step is to calculate error small e, tooth profile, then deformation factor capital C, and dynamic load FD by the Buckingham's equation. Let us start by first finding the error formula. This formula you can find on page number 17.15 and 17.16 of the Bhandari design data book. Let us find out first the tolerance factor phi. Phi is m plus 0.25 under root d. Now if you put dp, you will get phi p, and if you put dg, you will get phi g. So phi p and phi g you have to calculate. Then you have to first check which grade is given in the numerical. They would have mentioned that the gears are manufactured by grade 6, grade 7, grade 8, grade 9. Then if it is given by grade 7, then you can see in the table in front of grade 7 it is 11.00 plus 0.905. So you can find out the formula of E as 11.00 plus 0.90, and phi you already have calculated. I told you there, see below the table it is given m plus 0.25 under root d. So putting phi p value you will get EP value, and putting phi g value you will get EG value. So EP and EG as per the grade you will calculate, and once you find out the EP and EG value, you have to remember those values will be in microns. So you have to use the formula which is small e is EP plus EG. Once you do EP plus EG, you will have the value in microns. You have to convert it into mm, right? So 1 mm is 1000 microns, or 1 micron is 10 raised to minus 3 mm. So you have to multiply it by 10 raised to minus 3. Then you will get the value of error in mm. Once you found out error, the next step you have to calculate is deformation factor capital C. It is given as KE upon 1 plus EP plus 1 upon EG, where EP and EG are modulus of elasticity for pinion and modulus of elasticity for gear values. They would be given to you directly in the numerical. Now the next step is K, that is constant. Now constant K you have to select on the basis of the pressure angle. See, if it is 14.5 pressure angle, then the value of K is given 0.107. If the 20-degree full depth involute pressure angle is given, then small k value you will have to use at 0.111, and for 20-degree stub you will have to use it as 0.115. So either you can use this formula of C is KE upon 1 plus EP plus 1 upon EG, but what if EP and EG values are not given in numerical? Then see at the bottom of the video slide, you can see C is 11500 into E. Error you already have found out before the deformation factor. So you have to just multiply it with the error and you can find out C. But in this also, which C value you have to use, that depends on the material. If it is a steel pinion and steel gear, then the formula for C will be 11500 into error. If it is a cast iron pinion and cast iron gear, then it is 8900 into error. And if it is a steel pinion and cast iron gear, then it is 10000 into error. Remember, the unit for deformation factor is Newton per mm. This formulas you can find on page number 17.15 of Bhandari design data book. Now in 15th step we have to calculate the effective load based on precise estimation of the dynamic load by Buckingham's equation. So first we have to find out the dynamic load PD or FD, which is 21V BC plus FT max upon 21V plus under root BC plus FT max. You already know V is velocity, small b is face width, capital C is the deformation factor, and FT max is the maximum tangential load. All these V, B, C, FT max you have already calculated in the previous steps. You just have to put down into this formula the values into this formula, and you will get PD or FD, that is your dynamic load by Buckingham's equation. Below that the formula is just the change of notations. In Bhandari design data book on page number 17.15 you can find this formula. P effective is CS PT plus PD, and the other formula is just the change of notations. You can see CS is KA, right, which is your service factor or application factor. PT or FT is your tangential load. PD or FD is your dynamic load by precise estimation, and your KM is your load distribution factor. So this formula you can find on page number 17.15 of Bhandari design data book. 16th step, you have to calculate or say check your factor of safety. Now this you have to do in the basis of which one is weaker, whether it is gear is weaker in bending or gear is weaker in wear. Suppose the gear is weaker in wear. Let us say the gear is weaker in wear. You compared the value of FB and FW and you found that FW value is less. So you come to the conclusion that the gear is weaker in wear. Then your formula will be FW or SW is FS into F effective. Remember, FW or SW is your wear strength, and that formula you found out on in step number 7. F effective, recently effective load based on Buckingham's equation you found out in step number 15. So if I put the values of wear strength and effective load, I can easily find out the value of factor of safety. So now we will again go through all the 16 steps. First step is to calculate the number of teeth on gear from gear ratio. You have to find out ZG. Second step, you have to assume the face width if it is not given. Third step, you have to calculate bending strength sigma B. Fourth step, you have to calculate Lewis form factor capital Y. Remember, you have to see the pressure angle, which pressure angle is given, and accordingly you have to calculate. Fifth step is to decide whether the pinion is weaker or gear is weaker. Sixth step, you have to calculate the beam strength. Seventh step, you have to calculate the wear strength. Eighth step, you have to calculate the tangential load. Ninth step, you have to select the service factor CS or KA, load distribution factor KM, velocity, Barth factor CV or KV. 10th step, you have to calculate the effective load P effective or say F effective on basis of the preliminary estimation. 11th step, you have to calculate the module. So finally you will get the value of module in your 11th step. 12th step is to calculate all the dimensions of the gears pair like DP, DG, then your addendum, deadendum, center distance. All this you will calculate in test step number 12. 13th step, you have to calculate your maximum tangential load. 14th step, you have to calculate error small e, deformation factor capital C, and dynamic load FD. 15th step, you have to calculate the effective load based on the precise estimation of dynamic load, right? So you have to calculate your Buckingham's equation effective load, and then in 16th step you have to check your factor of safety. Thank you.